Good morning, learners, and welcome to this class. Today we will be looking at carbon and its chemistry, its various forms, its unique characteristics, and its various applications. Carbon is an important atom in life. Most of the living compounds, or what we will refer to as organic compounds, are made up of carbon. Carbon also facilitates the easier process of breathing out and breathing in. By helping us to breathe out, usually we release carbon dioxide. And after releasing it, it goes to plants or trees and they absorb them and use it in the process of photosynthesis to make oxygen, which we breathe in. Therefore, it is an important aspect in respiration. What are the properties of carbon? Carbon has got the unique ability to combine with other elements as a central atom, and hence it has got various properties. And these properties are a derivative of the fact that carbon can form a single, double, or triple bond with other carbon elements. It can form a maximum of up to 4 bonds. This allows it to form long chains, usually that are very long and not limited. They could be straight, they could be branched, or they could be in the form of rings. Examples are what you can see here. This is the simplest form of carbon combining with other elements. This is a case of a triple bond, a case of a double bond, a case of a ring, what we are calling as a ring, and in the case of a branched chain. But what makes carbon to form all those branched, ring, straight, very long or very short compounds or bonds with other elements, or elements that consist of carbon are known as organic compounds. And the simplest form is what we are calling as methane, and the structure of methane is as shown below. It consists of carbon and a single bond with 4 hydrogen atoms. Carbon, usually in its valence has got 4 valence electrons. Therefore, it can form 4 bonds for it to gain an octet state, or what we are calling as the stable state, as is the case in noble gases. This ability to form 4 bonds with other compounds, due to the fact that it has got 4 valence electrons, makes it form different compounds with other elements. This is in the case, look at the case of glucose and fructose, what we refer to as simply what we call as the simplest sugars that we have. These are made of carbon that is bonded with hydrogen and hydroxyl groups and a double bond of carbon and oxygen. The same case with fructose, except that the position of the carbon-oxygen double bond is different. Look at the other forms that can result from carbon combining with other elements. The case of cyclohexane and benzene, they form rings of carbon at various number of bonds. They could be single bonds or triple bonds or double bonds with hydrogen. There is also what we are calling as double bonds, where we see the case of 1-butene and 2-butene, where there are long straight chains of carbon and hydrogen with carbon-carbon bonds which can be either single or double. The same case for ethane and propane that form chains, straight chains, and these are formed of carbon, and carbon-hydrogen single bonds. There are also other forms of pure carbon, that is, they consist of carbon-carbon bonds with no other element that is substituting the carbons. These include diamond, graphite, fullerenes, and nanotubes. Let us look at each one of these and their unique properties and their uses. Diamond, for example, is a crystalline form of carbon that is formed when carbon-carbon atoms bond strongly with each other to form 4 other carbon atoms as shown here. Each one of these is a carbon atom combining with another. What is formed is a very strong element, what we are calling as diamond, and it has got high temperature, high pressure, high melting point, and can be artificially made. and usually it is used as a cutting tool in industries. The other pure form of carbon is what we're calling as graphite. Graphite is a form of carbon where carbon atoms are tightly bonded to 3 other carbon atoms to form what we are calling as flat layers, as shown. These bonds usually are very weak. And it is for this reason where, unlike the case of diamond that is used in industries for cutting, graphite is used as a lubricant in machines, and it is also the black part of a pencil, which we call as the lead in pencil, and usually it is graphite, not lead. The other form of carbon is what we are calling as fullerenes, that consist of carbon atoms that are arranged as a hollow spherical shape, as shown here. There is also what we call as nanotubes, that are carbons that are arranged in the shape of a hollow cylinder. They are usually extremely strong. As the bonds are strong, they are flexible, they can be moved or maneuvered. They are light and tiny, and they are good conductors of heat and electricity. Also, as we have seen, carbon has got the capacity to combine with other elements to form what we are referring to as organic carbons, organic compounds. And as we know, organic compounds are compounds that contain carbon. Many of these have got similar properties in terms of their solubility, electrical conductivity, smell, melting and boiling points, and usually they are in gaseous form, and they have very strong smell and do not dissolve in water. They are known as examples of these organic compounds. One of the most common examples are what we call as hydrocarbons. Hydrocarbons are simply made of carbon and hydrogen. They are usually either carbon-carbon bonds or carbon-hydrogen bonds. Look at the case examples that are provided here. This is a case of an element, a compound that is made of carbon-hydrogen bonds. This one has got a carbon-carbon bond and other carbon-hydrogen bonds. Usually hydrocarbons, just like other organic compounds, they mix poorly with water. They are flammable. A case of examples are ethane, what we have here, and methane, what we have here, and propane, as we will see in the next in the subsequent slides. The carbon chains in hydrocarbons, they could be straight, they could be branched or ring-shaped. The structural formula is that it describes the way the various carbon and hydrogen atoms or other elements are arranged and the number of bonds that are consisted in a single bond. For example, look at this element here. It is made of 4 carbon atoms that have got each a single bond, and these 4 carbon atoms are combined with other hydrogen bonds that also are single bonds. In the case of butane, it is the same as we have seen here. There are only single bonds of carbon-carbon and carbon-hydrogen. But in the case of isobutane, there are some double bonds of carbon and hydrogen and some carbon-hydrogen bonds and some that are single. The same case for this ring shape. But we have, even among the hydrocarbons, apart from their structural formula that consists of either single, double, or triple bonds, we have compounds that exist as isomers. Isomers are compounds that have got the same chemical formula. However, their structural arrangement is different, which makes them to have different properties. A case is what we are referring to isobutane and N-butane. In the case of N-butane, we only have single bonds, but in the case of isobutane, we have got some double bonds of carbon and hydrogen, and this makes them to have different physical-chemical properties. There are also other types of hydrocarbon which we refer to as saturated hydrocarbons. They only have single bonds. That is, the carbon-carbon and the carbon-hydrogen bonds are only single, as is the case with butane and propane. There are also what we call as unsaturated hydrocarbons. They could have triple or double bonds, but usually they have fewer hydrogen atoms compared to the saturated hydrocarbons. Examples are ethane and propane. The structure of hydrocarbons can also be substituted with other compounds. Usually they could be halogens, they could be alcohols, and organic compounds. In this case, let us look at the substitution of hydrocarbons by alcohols and organic compounds. In alcohols, usually one of the hydrogens is substituted with a hydroxyl group to form what we call as an alcohol. An alcohol is a hydrocarbon with a hydroxyl group that has been substituted in one of the hydrogens. Alcohols dissolve well in water. They have higher boiling points compared to other hydrocarbons. However, they have the similar number of compounds, number of carbon. The hydroxyl group that usually forms a bond with carbon or hydrogen is the one that influences the higher boiling points. We also have what we call as organic compounds. In this case, organic acids are hydrocarbons that have been substituted with a carboxyl group. What we can see here is a carboxyl group. Usually it is formed of carbon and through a double bond with oxygen and a hydroxyl group. Examples of organic acids are what we find in apples, that is malic acid, what we find in butter, butyric acid, what we find in vinegar as acetic acid, and what we find in lemons as citric acid. We also have what we call as esters. Esters usually are hydrocarbons that consist of both an alcohol and an organic acid that are part of the bonds that form the compound. Usually they are found in fruits such as strawberries, bananas, and pineapples, and they are the ones that control the fruity and pleasant smell in these fruits. We also have polymers and monomers. Polymers usually are long chains of hydrocarbons, such like you can see here plastic, motor oil, diesel, and gasoline. They are examples of hydrocarbons that form polymers or many chains of carbon and hydrogen bonds. A portion of one of these is what we are calling as a monomer. It is a smaller portion of a monomer. In our next class, we will look at the various examples of monomers and polymers and how they come into being. Thank you.